Hello and welcome to the OCP Global Summit for 2021. I'm David Wolf from the University of New Hampshire Interoperability Lab. I'm going to be talking about testing for the data center SSD specification. There's been a lot of interest in this specification over the last couple of years. If you've been following OCP, you probably remember that it was originally launched as the Cloud SSD specification. And at that time, the key contributors were Facebook and Microsoft. Since then, folks from HPE and Dell have joined that team to try and further enhance and refine the definitions that are in this data center NVMe SSD specification. Now, there's a lot of interest in this. And of course, if you are interested in it, the most important thing you can do is actually go and read the specification. It's posted publicly on the OCP website. If you go to the contributions database, you'll find that specification and you'll see those four key contributors listed there: Facebook, Microsoft, Dell, and HPE. But today we're going to talk about what is this data center SSD specification, why is there interest in it, where did it come from, how is it laid out, what does it cover, and then a little bit about compliance, how folks can test to this new specification and who might be interested in doing that. So first off, it's important to understand what the data center SSD specification is. And in order to understand that, we need to remember that this specification is really aimed at NVMe SSDs. It's almost like a profile, a data center use case profile for NVMe SSDs. Now remember that NVMe protocol is intended to allow easy, streamlined, highly efficient, fast access over PCIe to flash memory. And there are a number of use cases for that. Mobile use cases, client PC use cases, automotive use cases, and of course, hyperscale data center use cases. And the NVMe protocol is itself designed to be very versatile and enable all of these different use cases. What the data center SSD specification does is provide a profile for how to use the NVMe protocol in a way that's easily consumable in a data center. And aside from just defining like what optional features should be enabled or not, it also adds some features to make those SSDs even more useful in the data center use case. So remember that the NVMe protocol itself is kind of this generic way for talking to flash memory. But what if that flash memory is housed in an array in a data center? That's what the data center SSD specification helps us to realize and understand what the folks that are actually buying and using those SSDs, what they actually need for this use case. And you can see some of that even just looking at the chapter list in the data center SSD specification. There's NVMe requirements, which makes sense. This is purely aimed at NVMe SSDs. PCIe requirements, again, that makes sense. NVMe SSDs leverage PCIe. But then also there's things that are perhaps of particular interest when deploying NVMe at scale, like reliability, endurance, management, thermal, securities, and those kinds of things that kind of go far beyond what's required in the NVMe specification itself. And what we're going to do today is we're going to focus on the capabilities that can be tested and observed via the NVMe interface. So when you think about things like thermals, endurance, shock and vibration, there's a whole science around testing those things. What we're going to focus on today is just testing and observing the things that we can see on the NVMe interface. A similar approach that we would take for simply verifying NVMe compliance. Now, one thing that's nice about the data center SSD specification is that it's formatted as a requirements list, and each requirement has a unique requirement ID. So as you step through it, you can see very clearly what the requirements are. There's not a lot of narrative or explanatory text. It's just a very clear, the device shall do this, the device shall do that. And that's very helpful when you're trying to determine what NVMe optional features should be implemented or not. So we have an example here, just a quick screenshot from page 10 of the data center SSD spec. And you'll see on the left column there, there's some requirement IDs. And if you scroll towards the bottom, you see NVMe IO 8. The device shall support the compare command. Now, if you go to the NVMe specification, you'll see very clearly the compare command is optional. Datacenter SSD specification is building on top of that and saying, in this use case, compare command is required. And then right after that, fused operation of the compare and the write command. That's, again, something that's optional in the NVMe specification, but it's very important for this data center use case, and therefore it's required. So that gives you an idea of what you'll see as you go through that specification. And kind of a theme that you'll see is that it's an enhancement, a refinement, an expansion of the NVMe specification. How does it do that? Well, for one, it leverages NVMe 1.4b compliance. We'll get to that on the next slide. It requires or prohibits particular features that are optional in the NVMe spec. And then kind of really interesting thing is it defines some new features and new log pages that leverage the vendor-specific ranges from the NVMe specification in order to kind of provide greater capability. So let's get into the examples of this. First, leveraging 1.4b compliance for NVMe. You look at the very first page in the data center SSD specification, the very first requirement, device has to be compliant with NVMe 1.4b. And so really what the data center SSD specification is doing is it's leveraging all of the work that the NVMe organization has done with respect to compliance. So if you were to go to the NVMe Express website and you click on compliance, it's one of their top tabs, you'll get some information about proving compliance to the NVMe specifications, tools for that. Obviously, NVMe has partnered with the University of New Hampshire Interoperability Lab for many years on coordinating that compliance program. So that's kind of the first thing to note is data center SSD specification, it wants compliance to version 1.4b. Probably in the coming months and years, you'll see that get updated, right? NVMe 2.0 was released, I think around June of 2021. It would make sense that at some point you'll see this updated, but that's going to be a relatively easy transition for folks that are doing data center SSD specification because NVM Express is already kind of handling that compliance program and a lot of folks are working with it. So nice kind of partnership there. One note about NVMe specification and those letters. Sometimes folks get tripped up on this. The numbers in the NVMe specification name deal with new releases of the specification that have new features. So, NVMe 1.1 to 1.2, new features were added. 1.2 to 1.3, new features were added. 1.3 to 1.4, new features were added. In between those kind of big bumps represented by the number change with new features added, each of those specifications also had a series of letter releases. So the one referenced here is NVMe 1.4b. Prior to that, there was an NVMe 1.4a. What those letters reference is the integration of errata. So if they find that maybe a typo was made in the spec or something wasn't clearly defined or something got missed during the integration process, they want to go back and fix that. And that's what these errata are for. NVMe refers to them as ECNs. So when you see that B, you should know that that's saying this is the NVMe 1.4 spec plus some ECNs or some erratas. And in the case of NVMe 1.4b, the errata that have been integrated are 1, 2, 3, and 6. And again, you can go look on the NVM Express website. You can see exactly what those ECNs are. So again, the folks that created the data center SSD specification are telling us, yes, we want to see NVMe 1.4 compliance. We also want to see implementation of these particular errata. So something to pay attention to before you even get to page 2 of the data center SSD spec. Now, another example that we talked about for how the data center SSD spec leverages the NVMe spec is in requiring or prohibiting features that are optional in the NVMe specification. So a few minutes ago, we gave that example of the compare command. There's lots of examples of that in the data center SSD spec. So what we have on this slide, on the left, we have the data center SSD spec. On the right, we've got the NVMe 1.4b spec. And you can see on the left, the requirement ID NVMe IO2 says the device should support or shall support the dataset management command. Requirement ID NVMe IO4, device shall support the write zeros command. If you go look in the NVMe spec, if you look down there, bits 3 and bit 2 in the optional NVMe command support, again, optional NVM command support, write zeros and dataset management commands are optional to implement in NVMe. Datacenter SSD is not in conflict with that. It's just taking a step past that to say, for this particular use case, those commands are required. So it's something to pay attention to as you step through that spec. Now, kind of the really interesting thing that the Datacenter SSD spec did was define some new log pages and new features that leverage the vendor-specific ranges. So if you go into the NVMe spec, and we're showing that on the right, and I've highlighted there in yellow, there's a particular range of log page identifiers, which is vendor-specific. And different vendors have used those for a lot of different things, for performance metric, for health monitoring, that they want to keep track of, that part of their value add for their product. Datacenter SSD specification is kind of leveraging that range of log page IDs for things that are of interest to folks using SSDs in data centers. And you see the list there on the left, the smart health information extended log page, error recovery, firmware activation history, latency monitor, device capabilities, and then any unsupported requirements. So just another way for folks that are using these SSDs to kind of get a little bit more information out of the drive. And it's not just log pages, it's also features, new features that can be enabled and disabled on the drive. And there's several of these defined. You see them here listed: error injection, clear firmware update history, end of life or power loss, failure mode, clearing PCIe error counters, enabling the IEEE 1667 silo, again, latency monitoring, PLP health check, and then power states. And if you go open up the Datacenter SSD spec, you'll see that each of these features, both the set and get feature command for enabling them and configuring them, is very well defined in the specification. And then also the operation of these features is very well defined. So let's dig into a couple of those. C0H feature is the error injection. So creating these kind of very serious errors and testing how a device and how a host handles these serious errors as reported by a device can be very difficult because creating things like a CPU hang or a NAND hang or some other kind of hardware malfunction can be difficult. And so usually the way you need to do that is have some kind of special hook into the drive to get the drive to report that error up to the host. And then you can kind of exercise what the host's mitigation steps will be. Well, Datacenter SSD specification just tries to standardize that to allow the device to be able to configure the device to report a device panic. And there's a variety of errors here that it can report, and you see listed here, so that the host can see that and act accordingly. Now, it doesn't mean that those errors have actually happened on the device, but kind of mimics that behavior. So from the host perspective, it looks like that's happened. And so it allows, again, folks that are designing software for managing drives in a data center to test out how their host, how their drivers are going to handle those error conditions and do it in a predictable and standardized way across multiple suppliers. Because this is the kind of thing that maybe different suppliers had ways of reporting these kinds of errors, but they all did it a little bit differently. This standardizes that and kind of makes it easier for the folks that are, again, consuming and using the drives. Another one that's really interesting is the latency monitor. And you might have noticed that there's a latency monitor feature, C5, and there's also a latency monitor log page, C3. And via this feature, a host can set certain parameters for tracking latency and then use that log page to get those latency metrics. There's a ton of information on this in Appendix C in the Datacenter SSD specification that talks about how to record these latency events, calculating their duration, for different read, write, and trim operations. And again, kind of the goal here is to be able to debug very long latency events. So of course, latency of operations to a drive is very important. And it's been observed that in some cases, you'll see drives, the operations will finish with a relatively predictable latency for a long period of time, and then there'll be these outlier events that can be very troublesome. And so debugging those can also be difficult because they're, well, not always predictable. So this latency monitor allows the drive to record when those kind of outlier events happen. And that's going to make things easier when we go to debug what's causing that. So we've gone through what the data center SSD specification is. We've gone through some of the things, how it leverages the NVMe specification, some of the new features that were added. And you can see that it's a really nice approach for providing a drive implementer more information about really what their customer is looking for in order to use the drive in a data center use case. Now, just as NVMe has a robust compliance program for many years, a lot of folks have asked, well, how do we do compliance for this data center SSD spec? We're used to compliance for NVMe. That's great. That's going to continue. And in fact, that's part of proving compliance for the data center SSD spec. But what about all these other things in the data center SSD spec? How do we do compliance for that? Well, one really important thing to note is that the consumer of a drive for the data center SSD spec, this is an educated consumer. They know what they're doing. And they're trying to make engineering choices. So data center SSD compliance is multifaceted, it's multi-skilled, especially when we think about things like environmentals and around endurance and reliability. So it's not so much a yes-no thing in terms of compliance. Again, the purchaser is an educated purchaser. And so understanding exactly how the drive behaves and what its parameters are, that's going to be something that's really important to folks that are actually using these drives. And so when we get into compliance, what we're focused on today is things that can be tested at the NVMe interface and therefore can easily be validated by third parties, very similar to how we do NVMe compliance testing. And we have to recognize that some of the requirements might require special access that's not defined in the NVMe in the data center SSD spec, or they could have very, very long test times, especially get into some of the things along reliability and endurance. So there's going to be quite a few things that are necessary to check for the data center SSD compliance, and different users may be interested in different things about that. So definitely part of this is having a conversation with the customer. Now, in order to aid data center SSD compliance, some of those key contributors that we mentioned at the outset are working on a dedicated test plan for the data center SSD specification. And again, a lot of that is going to focus on what can be observed at the NVMe interface. We expect that to be published later this year. Perhaps at the time this is shared, it's already been published. And UNH-IOL is partnering on that, since we're, of course, very interested in supporting the community in compliance for the data center SSD spec. So expect that there will be a test plan published that will address that. Alongside that, we're doing updates to tools to make sure that the items that are in that test plan can actually be checked with a relatively simple tool set. So today, a lot of folks check NVMe compliance using the UNH-IOL tool. We're working on developing scripts and capabilities for that to kind of mirror that same kind of capability for the data center SSD spec. Some of that's even being demonstrated at customer sites now. Now, it's important to note that NVMe compliance tools, at least the ones from UNH-IOL, they can be run on kind of off-the-shelf hardware. Really, they leverage that PCIe interface, and it's really kind of a software-based test tool. But some of the things in the data center SSD specification require some specialized hardware. So you'll need NVMe protocol tools, PCIe protocol tools, the ability to cause PCIe resets, the ability to measure power consumption. And so those are some things. What we're looking at is using tools from Quark I think probably most folks who have done anything with SSD validation are familiar with their breaker modules. So this can allow us to reliably perform unexpected shutdowns, hot plug events, and things like that. And if you think about those kind of events, and then you think about data center SSD reliability, there's a lot that you can do to make sure that drives, if there is some kind of unexpected power loss, if there is some kind of unexpected hot plug event, is the host able to manage that? And so those are some of the capabilities that we're looking at adding to our tools in order to fully support data center SSD spec. There's also things in data center SSD spec around SM bus access. There are tools out there available for that. TCG Opal, there's test tools out there for that as well. So just be aware of the variety of things that'll be necessary for proving out a data center SSD compliance. So what can we do with all this information? As I said at the outset, if you're interested in the data center SSD spec, if you're interested in proving compliance to that, read the spec. That's the best thing that you can do to get familiar with what's going on there. We tried to give you a little bit of insight into what's going on in that spec today, but there's a lot more in there that we didn't have time to cover. So head over to the OCP contributions database, download that spec and have a look. The other thing to do is reach out to key contributors on implementation plans, understand what each of them are interested in seeing with respect to data center SSD product and data center SSD compliance. Also, as part of proving a data center SSD compliance, head over to nvmexpress.org and look at their compliance guidelines so that you can prove NVMe 1.4b compliance, because that's the first requirement in the data center SSD spec. And then keep your eyes open for data center SSD tools. As I said, at UNHIOL, we're working to expand what we do for NVMe compliance to also support data center SSD compliance in the same tool. Thanks everyone for your attention. It's exciting to talk about these new specs. It's exciting to see some key contributors and key customers in the industry sharing what their needs are when it comes to NVMe SSD implementation. So I hope this presentation was informative to you and hope you enjoy the 2021 OCP Global Summit.